have discussed the permutation versus combination, the relation between the permutation and combination, and the difference between a permutation and a combination. Simple, that is, permutation is nothing but the arrangement of things in which the order of things is also to be considered. In a combination, the order of things is not to be considered. That is why we have seen that NCR is equal to R factorial into P of N comma R. So that is, the selection can be lead to an arrangement, that is, a combination can be lead to a permutation with a simple multiplication of R factorial. Now, the things that are to be remembered, some results that are to be remembered, let us see now. In the first result, if you see the first result, some relations to be remembered. First one, you can see it is NPR plus R into P of, or you can write it in this way also, N minus 1 PR minus 1 is equal to N plus 1 PR. That is, totally how many things are there? N plus 1 things are there. How many things are taken at a time? R at a time. If you see this carefully, this N plus 1 is becoming N, R is same, N plus 1 is becoming N, and if you see this one, N plus 1 is becoming N minus 1 here. You can see this is R into P of NPR minus 1. So, understand this carefully now. There are N plus 1 things, dissimilar things, and R things are taken at a time. Then how it is split like this? What is this? 1 reduced, it becomes N, and here R taken. That means a particular thing is always avoided here. A particular thing is always avoided here. That means a particular thing is excluded. A particular thing excluded, understand. And if you see this one thing reduced here, and in R also one thing reduced. That means in both the cases one thing is reduced, but that thing is added here, that is included here. So this is nothing but a particular thing is always included, understand. So how do you understand this? This is the sum of a particular thing excluded and a particular thing is included is nothing but the total number of permutations. Understand it. N plus 1 PR is equal to NPR plus R into NPR minus 1. Of course, if you want to derive this, you can apply the formula N factorial by N minus R factorial. Here also, N factorial upon N minus R plus 1 factorial. And if you simplify this, you will be getting this, of course. But you must always say this formula using the principle of counting or fundamental theorem and arithmetic. What does it mean? A particular thing excluded, a particular thing always included. Let us suppose you are 6 friends. You are 6 friends attending an interview after your B.Tech. Let me say, attending an interview after your B.Tech for 4 posts. These 4 posts are into, one is into software development, another one is into admin, let me say, another one into operations, another one into marketing, let me say. Your 6 friends are attending for this 4 posts for an interview, and which are into different fields like this. Now, one of your friend taken recommendation from some minister, let me say, some minister. Then when he takes the recommendation of the minister, he must be included in one of these posts because he has that recommendation. So that is why what these people has to do, first of all, they have to accommodate your friend who has got some recommendation into any one of these posts. So he can be included in any one of these posts in how many ways? 4 different ways. Let me say, either software or admin or operations or marketing. 4 different ways. Into, now he is already included in one of these posts. How many posts are remaining? Only 3 are remaining. How many friends are remaining? How many of you are remaining? 1 is already excluded. So this is 6 minus 1, P 4 minus 1. See this one. 6 minus 1, P 4 minus 1, and it is 4, he is included. Then 1 must be excluded here. 1 must be excluded. So 1 is excluded and he is 6 minus 1, P. It is total number is taken to be 4. That is, it is nothing but 5P4 excluded. 5P4 is what? 1 is excluded and 4 are recruited. And 1 is included, but 5 are recruited into 3 posts. This must be equal to what? 6P4. You can check it out. It is nothing but 5P4. It is nothing but 4 into 5P3. Let us see this. 5P4 is nothing but 5 into 4 into 3 into 2 plus 4 into 5 into 4 into 3. You can take 5 into 4 into 3 common, and within the brackets you have 2 plus 4, which is nothing but 6 into 5 into 4 into 3, which is nothing but 6P4. You can see that. With this example, you might have understood. There are 6 people attending for an interview for 4 different posts. And among them, 1 has recommendation, that is why he must be included. He is included in 4 different ways. And the remaining posts, remaining people are recruited, and this is including a particular person. So to include this particular person, a particular person must be excluded even though he is talented. So that is why that particular person is excluded and 4 posts are recruited. That is 5P4 plus 4 into 6 minus 1 PR minus 1 is equal to 6P4. I have shown you the simplification also here. So understand, this is, when you see this one, don't see this as a formula. It is n plus 1 PR. It's not even n plus 1 total number of things are there, and r things are taken at a time. From n plus 1, only n things are chosen here, and n things are chosen here, and r things are taken, of course. So 1 is always excluded here. In this one, 1 is excluded, and here also 1 is excluded. That means in both the cases, 1 is excluded to include a particular person. So this is a particular person included, is a particular person excluded. Okay, now if you take an example on this problem, the letters of the word flower taken 4 at a time. 4 at a time. 4 at a time. Number 1, always F included. Okay. Number 2, let us say what is always F included. What is always F included? Here, F excluded. Second case. Always F included means what? How many are taken at a time? 4 are taken at a time. So how many are there? Totally 6 are there. From 6, F should be included first. First of all, remember, while working out the problems on permutations and combinations, you have to fulfill the restriction given. What is the restriction here? F should always be included. It can be included in how many different ways? 4 different ways. Either this or this or this or this. That means F is somewhere there. How many places are remaining? 3 places are remaining. In these 3 places, how many letters are remaining now? F is already included. How many letters are remaining? 5 are remaining. So 4 into 5P3. 4 into 5P3. Now F to be always excluded. F to be always excluded means remove F, and how many are remaining? 5 are remaining. For the 5, how many places are there? 5P4. Without any restriction, how many are there? Without any restriction, 6 are there, 4 are taken at a time. It must be 6P4. 6P4. So if you add these two, you must get this one, 6P4. Then I hope you might have understood this in a better way. This is flower. Always F included. Always F excluded. excluded. So if you add these two, you'll get total number of permutations. Now the thing is, if it is to be converted to a combination, what should be the difference? If it is to be converted to a combination, what should be the difference? And you think in this way, your 6 friends are attending for the entry of 4 posts. These 4 posts are into different fields previously. That is why we applied a permutation. If these 4 posts are into same, what is it? Software development. Let me say, then what makes a difference? Whatever the post is given, he will be satisfied with the recommendation. That means all the posts are similar. All the posts are similar with the same scale, with the same grade, and all are same. In such a case, there is no need of arrangement. So just imagine how this n plus 1 CR can be split now. How this n plus 1 CR can be split now? A particular thing is always to be excluded. A particular person is always to be excluded. Excluded means n plus 1 becomes n. And all are taken NCR. Plus, a recommended person to be included always. A recommended person is to be always included means what? That recommended person has 4 posts to get, so he need not be arranged, because all the posts are not different. They are into software development, means they are all similar posts. That is why this R will not be there in the combination. So what happens here? This becomes NCR minus 1. Understand it? So n plus 1 CR plus NCR minus 1 is equal to n plus 1 CR. N plus 1 CR is equal to NCR plus NCR minus 1. Understand? A particular thing is always excluded, a particular thing is always included. The difference is here arranged, here no need to arrange. That's what the difference between a permutation and a combination. Understand? That means, in this case, you can understand, Ganguly is to be always excluded in the cricket team. Sachin is always to be included in the cricket team. Then you'll get the total number of combinations. Understand? So, basing on this simple, this formula, you have a previous question on this one. You can see the problem placed on the screen now. Simplify. 47C4 plus sigma 52 minus J C3. J runs from 1 to 5. It's a previous question. That means why I'm discussing this, you can understand the application of this straight away. See, 47C4, here you have n, here you have n. This becomes n plus 1. So I want such a combination here wherein I'll get 47. So what I do, generally we expand sigma from lower to higher, but I'll expand sigma from higher to lower. So I'll substitute 5 here. So 52 minus 5 is nothing but 47C3. One term taken. Then what should it be? Sigma J runs from 1 to 4 now. 52 minus J C3. Understand it carefully now. NCR plus NCR minus 1. You understand this? NCR plus NCR minus 1, which is nothing but n plus 1 CR. N plus 1 CR means the higher value it will take, and for n, 1 will be added. So this becomes what? Just imagine, this becomes what? 47 becomes 48. And among 4 and 3, it takes 4. Because R minus 1, it takes R, 48C4 plus. What should be done? You can imagine now. What should be done? You can place 4 here. Place 4. Then this becomes 48C3 again. Plus. Let us write all the things, you will understand. Next, what should be next one? If you write 3, it should be 49C3. If you write 2, it will be 50C3. If you write 1, it will be 51C3. That's all. Everything is expanded now. Now this becomes what? 49C4. If you add that to this one, 50C4. If you add that to this one, 51C4. If you add that to this one, 52C4. Understand it? So when you know this formula, when you apply this formula carefully, you can write this answer directly, please. Okay, that's what it is. Go to the 16th slide. So this is an important formula application which you can find in the previous questions. Okay. So here now, coming to the next one. It is simple one. For the simplification purpose, we will make use of it. Third one is NPR upon NPR minus 1. Just I don't want to explain you that more, because by applying the formula NPR, you can simply get that whenever you come across such type of permutations. Third one, NPR divided by N minus 1 PR minus 1 is equal to N. Apply the formula and simplify, you'll understand it. Whenever you come across such type of numericals, you can write the answer directly, like if you have 15C5 upon, that is N is given to be 15, R is given to be 5, divided by 14C4. 14C4, that is 1 reduced here. In this case, what should be the answer? It should be the answer. 15 should be the answer. That is P, 15P5 upon 15P4. 15P5 upon 15P4 is equal to 15. This is very simple thing. You can understand that. Next one also similarly, NCR upon NCR minus 1. Fourth one, NCR upon NCR minus 1 is equal to N minus R plus 1 upon R. Simplify that, you'll be understanding that. Permutations of N distinct things, very important one. Fifth one, please. Generally, what happens when we work out the problems, you don't get the idea of this. That is why I have chosen this. Permutations of N distinct things if the order of R things not to be considered. The order of things not to be considered is N factorial upon R factorial. Order of R things not to be considered means what? There are N persons. Let me say. Those N persons are to give a speech. In the speech, generally let us suppose a political meeting. In the political meeting, Prime Minister has come, and Chief Minister has come, and Home Minister has come, and President has come. And there will be some formality, there will be an order for those persons to speak. That means, well, first of all, Prime Minister should not speak before the President. So President has to address something like that. Some protocol will be there. Some protocol will be there. In such a case, the order of those 4 persons is not to be considered among with the others. Among with the others. In such a case, what should be the permutation? Okay, let's have a problem on that one. Go to the previous slide. This one, there are 7 persons. And among them, A, B, C are 3 persons. Whose order is not to be considered? Whose order is not to be considered? Whose order is not to be considered? Then in such a case, then how many permutations can be made? That means these 7 persons are to speak in a meeting, and in that one, ABC order is not to be considered. ABC order is not to be considered. ABC order is not to be considered. In such a case, how many permutations can be made? How many permutations can be made? See this one carefully. Now, this is 7 persons generally can be arranged in, just wait. See that one on the screen, please. Third problem. A, B, C are 3 persons among us 7 persons who speak at a function. The number of ways in which it can be done if A speaks before B and B speaks before C. What does it mean? A speaks before B and B speaks before C. It doesn't mean that A speaks before B means it need not be immediate. B speaks before C, matlab it need not be immediate. It may be placed anywhere. First A speaks, then only B speaks. B may be anywhere, but A must speak first. And after that B speaks. And after that C speaks. That means how many without restriction are there? 7 minus 3. 4 are there. 4 persons are there without restriction. Then ABC should be placed in such a way that if A is placed here, B must be placed in any one of these 2 places. Because C must be accommodated. And if A, B are placed, C must have a place behind B. That means ABC can be placed anywhere in this blank places, but you must understand that they must be placed, they must speak in such a way that A speaks before B and B speaks before C. That means you understand it whenever you come across this type of problems. Understand that the order of 3 persons is not to be considered. The order of 3 persons is not to be considered. What does it mean? Then 7 factorial upon 3 factorial. Understand, very simple. 7 factorial upon 3 factorial. 7 factorial upon 3 factorial. So what should be the answer? You can imagine that 7 factorial is to be divided with 3 factorial. That is, it is 5040 upon 6. Simplify that, you will get the answer. So simple thing. I'll answer your question, Aishwarya. What is it? How many 3-digit numbers X, Y, Z with the X, comma, Z less than Y can be formed? Isn't it? We'll answer that. So understand whenever the order of the things, 16th slide. So whenever the order of things is to be is not to be considered, then simply it is n factorial upon r factorial. Fifth one please. Permutations of n distinct things. If the order of r things is not to be considered, is n factorial upon r factorial. Next, 6th one is NCR is equal to NCN minus r. What does it mean? NCR is equal to NCN minus r means, what is the meaning of NCR? Let us suppose there are 30 students in your class, and from 30 students or 15 students are taken, or 12 students are taken, let me say 30C12. The group of 12 students is to be formed. Then 30 students are sitting in the class. I have separated 12 students from them, and how many will be remaining then? 30 minus 12 will be remaining. So that is 30C 30 minus 12. If I make a group of 12 students, automatically another group of 18 will be remaining. That means the number of ways of making a group of 12 students from 30 students is equal to number of ways of making a group of 18 students. Understand? So 30C12 is equal to 30C 30 minus 12. That is 30C12 is equal to 30C18. That is NCR is equal to NCN minus R. This is only used in the binomial theorem. You know that the binomial coefficients are like this: NC0, NCN, NC1, NCN minus 1, NC2, NCN minus 2. That means NC0, NCN are equal, NC1, NCN minus 1 are equal, NC2, NCN minus 2 are equal. You can understand that. That is why, basing on this property only, in the expansion, the binomial coefficients are used. Okay. Next, 7th one is important one. You can find some previous questions also on this one. NCR is equal to NCS, implies N is equal to R plus S, or R is equal to S. Understand this. N is equal to R plus S, or R is equal to S. Okay. Now, these are some relations are to be remembered. Now, to answer that question of Aishwarya, we have to work out some problems on the combinations. After working out the problems, we will answer that question. It is the geometrical applications is the topic today. Geometrical applications of combinations. So what are the geometrical applications? Geometrical applications means, you understand, see that one carefully, the number of diagonals in a regular polygon of n sides. The number of diagonals of a n-sided polygon. Rather, I have taken 1, 2, 3, 4, 5, 6 hexagon I have taken. What does it mean? The number of diagonals means how many diagonals will be there for this one, joining any two sides like this. So how many points we need? How many points we need to form a diagonal? How many points we need to form a diagonal? Diagonal is consisting of anyway 2 points. So a 6-sided polygon, that is hexagon, how many vertices it has? 1, 2, 3, 4, 5, 6. In this 6, we need a diagonal. Diagonal means it consists of 2 points. So I will choose 2 points. I have applied 6C2 here. Then you may think, why not 6P2? Not needed, because it's a line. It's a line. If it is a vector, then you have to apply P here. It's not a vector. Vector means AB bar different from BA bar. Different from BA bar. They are like this, you can say. Differs with 180 degrees. So these are not vectors here. If it is vector, you have to apply P here, but these are the lines. So 6C2, I say, 6C2 diagonals can be formed, but among them you understand, these 6C2 may be sides also. This is one side, this is not a diagonal. This is side, not a diagonal. This is side, not a diagonal. This is a side, not a diagonal. This is a side, not a diagonal. How many sides are there? 6 sides are there. 6C2 minus 6 are the diagonals. What does it mean? 6 into 5 upon 2 minus 6. It is 15 minus 6. It is nothing but 9 diagonals can be made. So, basing on this, you understand now how n-sided polygon can be considered to find out the diagonals. So, diagonal requires 2 points. N-sided polygon will have n vertices. From n vertices, how many I need to form the diagonal? 2 I need. So NC2. But in these diagonals, n are sides. These diagonals, n are sides. So NC2 minus n. So it should be like n into n minus 1 upon 2 minus n. So what should it be? N by 2 taken common, n minus 1 minus 2, which is nothing but n of n minus 3 upon 2. Understand it please clearly. So the number of diagonals that can be formed from an n-sided polygon is nothing but n into n minus 3 upon 2. That's what you can see there. So you can understand that the number of, this is a geometrical application of combinations, that is n into n minus 3 upon 2. Come to the second one. The number of parallelograms formed when a set of m parallel lines are intersecting another set of n parallel lines is MC2 into NC2. MC2 into NC2. What does it mean? There are one set of parallel lines like this. And this is given to be M there. And another set is there. And this is given to be some n. Understand, to form a parallelogram, either this or this or wherever you take, to form a parallelogram, how many sets of parallel lines we need? This is one set. This is another set. One set is to be chosen from M. Another set is to be chosen from N. Understand? So, first operation of selecting two lines from M can be done in how many different ways? MC2 different ways. Second operation of choosing two lines from N can be done in how many different ways? NC2 different ways. So, MC2 into NC2. First operation, second operation. So, the number of diagonals that can, the number of parallelograms formed from a set of M parallel lines and from the set of N parallel lines. M and N is nothing but MC2 into NC2. What is this 2 here? We are choosing two lines from the first set. We are choosing two lines from the second set. And first operation, second operation simultaneously can be performed in MC2 into NC2 different ways. Understand this carefully. Next slide, please. If there are n points in a plane, no three of which are on the same straight line, excepting p points, which are collinear, then the number of straight lines formed by joining them is. Follow that carefully, please. If there are n points in a plane, how many points are there in the plane? N points. It's a problem. Let us suppose there are n points on a plane. From n points, no three of which are on the same straight line, excepting P points which are collinear. All the points are not lying, no three of these are lying on the same line, but only P points are lying on the same line, like this. Let me say, these are P points. Totally how many points? You can see the slide there. N points are there on the plane. From n points, how many points can be chosen to form a line NC2? Understand? To get a line, how many points are needed? 2 points are needed. This is 1, 2, 3, 4, 5, 6, 7, like that. How many lines can be formed? NC2 lines can be formed. But the problem is, here, all these P points are lying on the same line. That means they will not form PC2 lines, but they form a single line because they are all lying on the same line. So understand, these PC2 are also included in this one, but they are not PC2 lines, but they are one line. That is why it is to be subtracted, NC2 minus PC2. But the entire P points form a single line. That single line is of course to be added. So plus 1. So when on a plane n points are there, among them P points are collinear, then the number of lines that can be formed are NC2 minus PC2 plus 1. Understand? So similarly, number 2, the number of triangles formed by joining them is number of triangles formed. To form a triangle NC3, you know that, because to form a triangle, how many points we need? 3 points we need. So 3 points are chosen, minus these P points will not form a triangle, but they form a straight line. So minus PC3. So you can see that. Now the number of triangles formed by joining them is NC3 minus PC3. So understand, this is also a geometrical application of combinations. Like this, you just think of applying the combinations for the geometrical applications. Let us work out a few more problems on that one. Go to the next slide. So now, if you see the problem on the PPT, please. That one, if a polygon has 35 diagonals, then the number of sides of the polygon is. Can you try that one? Please try that one. If you see, the question given is very simple question. The number of diagonals of a polygon are nothing but 35. Then find the number of sides of the polygon. We don't know the number of sides of the polygon. Let them be n. To find out the number of diagonals, you need 2 points, because n vertices will be there. It is NC2. 2 points are chosen. But in this one, the sides will also be there. Side is not a diagonal. That is why it is to be subtracted. NC2 minus n. Just now I explained you. That's what is simplified, and it was given to be n into n minus 3 upon 2. Which is here given to be 35. Understand that, please. If a polygon has 35 diagonals, then the number of sides of the polygon means n into n minus 3 upon 2, which is nothing but n into n minus 3 is equal to 70. N into n minus 3 is equal to 70. This 70 is nothing but 10 into 7. So n into n minus 3 is equal to 10 into 7. So n is equal to 10. N minus 3 is equal to 7. So what should be the answer there? N is equal to 10. So the number of sides, the number of diagonals are 35. The number of diagonals are 35. Then the number of sides will be 10. So what should be the option there? 10. 10 is the option, that is option D is the correct one. Next one, the number of triangles whose vertices are the vertices of an octagon the number of triangles whose vertices are the vertices of the octagon, but none of whose sides happen to come from the sides of the octagon. None of whose sides happen to come from the sides of the octagon is. Before answering this question, let us have a general problem of n-sided polygon. Go to the next slide. Now go to this, please. If there are n points on a circle, then find the number of triangles that can be formed by using these points such that no two consecutive points are chosen. What does it mean? There is a circle. On the circle, how many points are there? N number of points are there. Now you have to form the triangles in such a way that there should not be 2 points consecutively chosen. That means this is we don't want. This we don't want. But we need this. Because these two are not consecutive. In between these two there are 2 points. In between these two there are 2 points. So understand. Now, how many such triangles can be formed? So for your better understanding, what I do, I'll take a hexagon. Because hexagon, you can clearly construct such triangles. For the better understanding, I have taken a hexagon. Hexagon, how many sides it has? 6 sides. How many vertices it has? 6 vertices. 1, 2, 3, 4, 5, 6. 6 sides, 6 vertices. Now, how many triangles can be formed in such a way that no side of the hexagon should be the side of the triangle. That means, if you draw this is one triangle which we need because these two are not consecutive. In between them, one vertex is there. Now, if you see, this one also needed. So, how many triangles can you see now? This is first triangle needed. This is second triangle, it is also needed. You understand? You can see a clear star there. Okay. So, according to our question, there are only 2 triangles that can be formed such that no side of the hexagon should be the side of the triangle. Now, let us apply the concept of combination now. Combination. How many vertices are there? 6 vertices are there to form the diagonal or to form the triangle. To form the triangle, how many vertices are needed? 3 are needed. Taken. 63. 63 is nothing but 6 into 5 into 4 upon 3 into 2, which is getting cancelled. That is 5 into 4, 20. So, if you apply the combination, you are getting 2. But practically, if you see, these are only 2 triangles. So, what is happening here? What is happening here? Minus. If you see carefully, let us take this side AB. For AB, with AB as side, the triangles are also included in this one. With AB as a side, the triangles are also included in this one. So, which are not needed, but they are included in this one. So, how many such triangles can be formed with AB as side? Let us see. With AB as side, let us see. That means you must not take these two. You can take. That means this is not taken, this is not taken. But this can be taken like this. This is one triangle. And this is another triangle. So understand, with AB as side, how many triangles that can be formed? Here 2 triangles can be formed with AB as side. So how many such sides are there? BC is there, CD is there, DE is there, EF is there, AF is there. 6 are there. That means for AB you are getting 2 triangles which have AB, that is the side of the hexagon as the side of the triangle, so which is not needed. So each 2, how many are there? 6, 6 into 2 minus. But you will find such triangles which have, I'll draw this separately so that you'll understand it in a better way. What I did now, I have taken AB, I am counting those triangles which are not needed. This is one triangle. this is another triangle, not needed. That means with AB as side, this is one triangle. With AB as side, this is second triangle. So two triangles, not needed. So how can we take n is equal to 6 as there are n sides? For the better understanding, I am taking an example. Now we will generalize it to n. We will generalize it to n. Your question answer, Miss Lalita. We are generalizing to n now for the better understanding. 2 into 6. Now, similarly, if you have same like hexagon, this is two sides are there, A, B, C. This is one triangle formed with two sides. Another triangle, another triangle, another triangle, another triangle, another triangle with two sides as common sides. Then it is minus 6. So what should it be? Minus 12, minus 6. What should it be? Minus 18. What should it be? Two triangles. According to our construction, you have got two triangles. Now let us generalize this to n sides, Miss Lalita. Just listen to me now carefully. N-sided polygon. This is nothing but a polygon. On the circle also, the polygon will be formed because no 3 points will be collinear on this case. No 3 points will be collinear. So from this one, we will find out NC3 minus here. How do you get 6 here? 6 is 6 sides. For n-sided, n sides into. For AB, these adjacent points are not taken. AB adjacent points are not taken. That means it is nothing but 6 minus 6. Totally 6 are there. So how many points are avoided? 4 points are avoided. So 6 minus 4. C, how many points are taken? 1. 6 minus 4, C1. So it is nothing but n minus 4 C1 minus what is 6 here? Two sides form 6 triangles. I have shown it here. So for n sides you will form n. So if you simplify this, n of n minus 1, n minus 2 upon 3 into 2 minus n into n minus 4 minus n. If you simplify this, you will get as you can understand the answer now. It is NC3 like 63 minus n into, that is 6 into, what is 6 here? 6 sides. Here, how many? N sides. So you may be getting confused if I draw like this. So n sides means they will be formed. This is nothing but a hexagon only. I present it in another way on a circle. So here in place of 6 you must get n. And in place of 6 minus 4, you must get n minus 4. 1 point is taken to form the triangle, that is 1 minus 6. Here 6 triangles are formed. That is why minus n. So if you simplify that, you can see that it is n of n minus 4, n minus 5 upon 6. If you can remember, it will be better. So if you go to the previous question now, Sixth question, the number of triangles whose vertices are at the vertices of the octagon, but none of whose sides happen to come from the sides of the octagon. What is n in this case now? What is n? Please apply and tell me the answer now, because you are asking the doubts. Let me see how many of you answer this question based on this formula, please. Here, it is an octagon. For an n-sided polygon, I have derived the number of triangles that can be formed in such a way that no side of the hexagon is the side of the triangle. So that means this is one required triangle. Like that, because these two sides are not included in this triangle. Any side of the hexagon is not included in the triangle. So now it is an octagon. The same concept. It is an octagon means put n is equal to 8. So this is what you will understand now. 8 by 6 into 8 minus 4 into 8 minus 5. Simplify that, you will get the answer. So the presentation of the question is different. This is same as the 7th question. The number of triangles, here the number of n points are lying on a circle. Lying on a circle is same as the forming of a polygon. Both are same only. Both are same only. So for that one, you can take this as a trick to apply. That is n into n minus 4, n minus 5 upon 6. Okay. Go to the next one. The number of rectangles that can be formed on a chessboard. The number of rectangles that can be formed on a chessboard. So Aishwarya's question will be answered through the mail, and let me see that, and I'll answer that question. Let me I'll give a reply to that one. Okay, now in this one, because the time is not sufficient to discuss that, the number of rectangles that can be formed on a chessboard. On a chessboard, you know, 1 2 3 4 5 6 7 8 9 vertical lines will be there. Similarly, 1 2 3 4 5 6 7 8 again 9. So on this one, we need the number of rectangles that can be formed. Number of rectangles that can be formed. Follow this carefully, please. This is one square, of course. Square is also a rectangle. This is another rectangle. This is one rectangle. This is another rectangle. This is another rectangle. So this is another rectangle. So like that, how many rectangles will be there on the chessboard? That's what is needed here. So here, how many lines or vertical lines are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 vertical lines are there. How many horizontal lines are there? 1, 2, 3, 4, 5, 6, 7, 8, 9 horizontal lines are there. So to find out the number of rectangles, whatever the rectangle you take, there will be one set of parallel lines. And in the second set also, 2 lines will be there. To form the rectangle, 2 lines should be taken from the vertical set, 2 lines should be taken from the vertical set, and 2 lines should be taken from the horizontal set. Understand it? From the vertical set, 2 lines to be taken. From the horizontal set, 2 lines to be taken. So, first operation, what I do? I'll choose 2 lines from the horizontal set. First operation, I've been repeating that whenever you solve any problem related to permutations and combinations, you always split it into operations so that it will be more comfortable to you. First operation, what we are doing, we are choosing 2 lines from 9 lines. Chosen. It can be done in how many different ways? 9C2 different ways. Second operation, this is horizontal lines we have taken 9C2. From the vertical lines also, you can choose 2 lines in how many different ways? 9C2 different ways. So first operation can be performed in 9C2 different ways. Second operation can be performed in 9C2 different ways. These 2 operations, one after the other or simultaneously, can be performed in how many different ways? 9C2 into 9C2 different ways. What is 9C2? 9 into 8 upon 2 into 9 into 8 upon 2, which is nothing but 36 into 36, which is nothing but 1296. You can see the answer there. It is option B. It is option B, 1296. So the number of rectangles that are present on the chessboard are 1296. Now if you see the next question, the number of squares that can be formed in a chessboard. The number of squares that can be formed on a chessboard, just you go through the question and answer it on your own, and if you get the answer, that will be good. Otherwise, we will see this in the next class, and we will be discussing more and more questions only in the coming 2 sessions. We'll be discussing more and more questions only in the coming 2 sessions along with concepts. So you try this one. I have explained you the number of rectangles, and 9th question, which is on the slide, you can see the number of squares that can be formed on a chessboard. You find it out, please. Okay, if you get the doubt, we will clarify that in the next session. Next 2 sessions will be the problem solving sessions, and the Miss Aishwarya's question will be answered through the mail, otherwise in the next session.